So our next speaker is Saampras Ganesan. Saampras is a PhD student in Melbourne in our group, and he's done all of the heavy lifting in terms of putting together this symposium. So over to you, Saampras.
Thank you. Thanks, Andrew. So here I'm going to talk about ultra-high field neurofeedback and also the utility of sampling at the real-world state. So we specifically targeted a particular kind of task, so in this case meditation. As you can see, meditation kind of cycles through different states where you try to pay attention to your breathing, you get distracted by thoughts, and you notice the distraction, and you try to switch your focus back to breathing. So in simple terms, it's just trying to train your attention to present moment with non-judgmental awareness. Most of you may have tried it at some point. Research has shown that meditation has a lot of mental health benefits, and it improves emotion regulation and control over negative thinking. And it has been used to target a lot of clinical populations through structured meditation and mindfulness programs, as well as healthy cohorts. But it is not easy to do. It is challenging, especially for beginners as well as clinical samples, because limited awareness is something that we all struggle with. Limited awareness of what our minds are doing, and distractions keep arising when we try to meditate, and the attention is quite volatile. So as a consequence, it can be difficult to learn meditation, time-consuming, can be frustrating, and a lot of people even give up before actually beginning to realize its benefits. So we wanted to see what can we do using neurofeedback to help with this. So our goal was to simply teach beginners to meditate using neuroanatomically precise neurofeedback, so that's why 7 Tesla fMRI. And we also wanted to examine the acute and the enduring effects through longitudinal ecological sampling and follow-up. So ecological sampling in this sense means trying to understand how people are in the real world and kind of try to measure their meditation in the real world. Now, this is kind of also addressing the general limitations in the neurofeedback field, because there have been very few studies that have explored neurofeedback with 7 Tesla, despite the higher spatial and temporal resolution, and also statistical power. And the other aspect that we're targeting here is generally neurofeedback studies have had limited follow-ups, and there is only an emerging kind of movement to demonstrate translational impact. But what intervention is useful without translational impact? So that's kind of the goal of the field right now. So before we proceed, we need to look at what we need to feed back to people, because brain target is important here. So we looked at the meditation literature, and we found several regions that were quite consistently implicated across meditation studies in fMRI, but the posterior cingulate cortex is somewhat most strongly implicated, and it's also associated with mind wandering. So in essence, during meditation, what you try to do is reduce mind wandering, so diminish mind wandering by trying to pay attention to your breathing, and so you diminish your PCC activity. And it's not just that, because meditation is a very complex activity. We've also found that models of meditation show that the default mode network also kind of interacts with other networks like the salience and the executive control. So it's kind of cycling through different states, and different network interactions kind of facilitate that. So moving to the scanning attributes, so what did we really look at here? We used 7 Tesla MRI, as I'd mentioned before, and this is from the Melbourne Brain Center Imaging Unit. The temporal resolution was quite low, so 800 milliseconds, which is quite quick for neurofeedback, and we had a multi-band factor of 6. And also, well, not really sacrificing our fMRI spatial resolution, so it was 1.6 millimeters. We also used concurrent pulse ox and respiration belt measurements. Now, looking at the study itself, So we had about 39 people here. Again, healthy novices. We wanted to train beginners. We wanted to, it's a proof of concept study in 7 Tesla, so we wanted to kind of look at healthy people first. And we divided the sample into 2 groups. So one group receives real neurofeedback from their own PCC. And note that here, like as the other speakers have already introduced us to, denoising is important, and it's also important specifically in 7 Tesla. So we used a midline structure, which comprised of a lot of midline regions known to be involved a lot in respiration, as well as CSF and white matter. So we kind of used those signals to control for this PCC signal in real time before feeding it back. And again, this was fed back intermittently. So participants meditated for a while, and then there was feedback, and then they meditated, and then there was feedback, and so on. Now, this is the real feedback group. But there's another group here. This is the control group. It's called yoked sham. But what do they really do? They do exactly the same thing as the real group. They go through the same instructions. They meditate the same way, and they see everything that the real group sees. The only difference is that their feedback is not from their own PCC. Rather, it's from the PCC of another participant in the experimental group. So we match these participants based on their meditation experience. So this allowed us to kind of control for a lot of factors like motivation, frustration, placebo, the perception of success, and so on, to ensure that what we're looking at here is really the effect of neurofeedback from that particular region and not just other non-specific factors. So in terms of the study protocol, it was randomized, controlled, single blind. So the participants did not even know that there was another group here. So they all thought there's just one group and everybody's receiving real neurofeedback. It was also longitudinal, which I'll get to in a bit. And we used the Turbo Brain Voyager software. All the real-time analysis involved was getting percentage signal change. So it was a very simple kind of estimation of percent signal change in the PCC during meditation with respect to a non-meditative state. So in this case, a control condition, which is rest. We did online detrending and motion correction, and also the PCC areas were personalized for each participant. The goal was basically very simple. Try to meditate, and in the process, try to reduce your PCC activation. So, looking at the study design, this was a very kind of extensive study design, but I'm not going to cover all aspects of it. What I'm going to focus on is, so there was something missing. All right, what I'm going to focus on is just baseline. So during baseline, what people did really is come in and have a few measures taken. The important thing I want to highlight is the 5 minutes of unguided meditation. So this is where they just come in and they're given instructions to meditate, and then we assess this state mindfulness, so which is kind of telling us the participant's perception of how consciously aware they are of their mental activity. So that's on baseline, and then they come back on day 1, which is when they do the neurofeedback training with mindfulness or with meditation, and again, the state mindfulness at the end. Day 2, identical, and then they go back home. So now, during 1 week after this neurofeedback, they are asked to meditate at any time of their convenience in the real world. So they could be at home, they could be at work, whatever. They've got an app, and they just do the 5 minutes of unguided meditation, and they're administered the same measurement, which is kind of trying to get at the conscious awareness of their mental activity. It's a validated scale in the meditation literature. And then follow up after 1 week, so they do the 5 minutes again, and we've looked at another measure, which is the task 21. So that's kind of covering mental health and emotional distress. So these are kind of our main primary outcome measures we wanted to look at: mental health and meditation practice. Now, in terms of the neurofeedback itself, they came into the scanner. The first thing they did was baseline. So this baseline did not involve any neurofeedback because we wanted to kind of get them to meditate in the scanner without any feedback first, like do it as you know it and as you've learned through this initial pre-baseline sessions. And then we went ahead with neurofeedback. So they go through a period of 1 minute of restful thinking, and then you've got 30 seconds of meditation, and then the feedback pops in for that meditation period, and then 30 seconds of meditation, feedback, and so on. So we did this over a couple of sessions. And after that training, they again came out, they were in the scanner still, but they did the transfer session, which is again without neurofeedback. So this is where we're trying to explore the transfer effects of that neurofeedback training. So I'm just going to quickly go through what we were looking at here. So we were looking at the PCC response during neurofeedback meditation on each day. So as I mentioned, there are 2 days of training. We looked at general linear modeling, which is a very traditional approach, univariate statistics of PCC deactivation. But as I mentioned before, with meditation, you also kind of have a lot of interactions with other networks. So we also wanted to look at task-dependent change in functional connectivity between PCC and the whole brain. So this is using PPI analysis, which kind of looks at the change in coupling between regions as the task progresses, so during different task blocks. We also wanted to look at, of course, whether those changes were kind of available in the non-neurofeedback session, so during transfer, during baseline, and so on. So again, we looked at the FC there with the PCC, and this is offline. So we're not looking at this online, we're looking at this offline, which means we have the luxury of doing all these very stringent denoising and statistical approaches. And with respect to behavioral, we wanted to look at the acute state of mindfulness after each MRI day. So when they come out of the scanner, what do they feel? How do they feel in terms of mindfulness? We wanted to look at how emotional distress was changing over the course of 1 week. And also we wanted to importantly look at the rate of improvement in meditation quality over 1 week. So this is important because this is what they're doing in the real world. They're going out of the scanner and they're just practicing meditation at home. And finally, we wanted to look at all these measures and how they were kind of related with the brain measure that we were looking at. So before I present my results, I just want to first look at or show you the validation aspects. So there are 2 key points to validate here. Was the neurofeedback signal that we fed back to participants from the PCC, was it really related to PCC itself when we checked offline? Turns out it was. So it was a significant correlation. That means the meditation, the PCC signal that we fed back to participants during neurofeedback was correlated with the offline derived PCC signal. And the other aspect we wanted to look at was blinding. So given that both participants were going through exactly the same intervention, the only difference was one participant received real neurofeedback, the other one received sham neurofeedback. So we wanted to look at how they perceived that. So were they able to find a difference in the whole intervention? Were they able to kind of look at the feedback and say, oh, well, it doesn't correspond, or it corresponds too well. So there was not much of a difference between the 2 groups, which kind of shows that the perception was kind of equivalent between the groups, so which is what we want here. Now, looking at the brain changes first. So this is a little bit of a bummer because the groups did not really differ in terms of deactivating their PCC. But the good news is that both groups were able to deactivate. So this is kind of task fMRI, right? So you go through a meditation block design and you try to meditate, pay attention to your breathing, reduce your mind wandering, and you deactivate your PCC, and both groups are able to do it kind of equally here in terms of deactivating. But there was a difference though, because on day 2, the experimental group was able to deactivate the PCC while also increasing the decoupling or the anticorrelation between the PCC and the DLPFC, or the dorsolateral prefrontal cortex. So this is an important finding because this connection has been implicated quite a bit in meditation, in the quality of meditation, in attentional vigilance, and so on. And we also found that same connection, so the exact same connection, showed the same kind of effect even in the transfer, so in the non-neurofeedback meditation sessions. As you can see here, this part is not significant, but even though it's not significant, you can see that the experimental group is kind of decoupling the PCC and the DLPFC, more so than the control group. So what does this all mean? Both groups are deactivating their PCC, but one group is kind of able to increase their DLPFC more. So this is kind of showing that the experimental group learned to control their mind wandering even more and control their self-referential processing even more than the control group. The experimental group was able to do it. So then looking at the acute meditation-related effects, we wanted to look at, as I'd mentioned, state mindfulness. So it's kind of telling us about how aware they were of their mental activity. You can see that the experimental group was actually quite improving in that over time, whereas the control group was not. And importantly, this improvement was also related to that specific coupling between the PCC and the DLPFC. So we've not just got state mindfulness that's improving, but we've also got that improvement to be linked to the specific connection that was different between the two groups, whereas that was not the case for the control group. And we specifically looked at day 2 here because that's where the change was. So in essence, the experimental group experienced greater mindful awareness of mental activity after meditation, so right after the neurofeedback meditation, which is actually related to the decoupling during meditation. And finally, we also wanted to look at enduring real-world effects. So this is really where the translational impact of such interventions kind of shows. So this is kind of showing us how the meditation quality of the experimental group participants improved over time, whereas the control group kind of went a little bit lower. Is a significant group in the slope interaction. This kind of shows how the neurofeedback training was able to show effects even during their day-to-day meditation practice at home. Greater mindful awareness during meditation over time. And finally, mental health. So this is at the end of the day, this is what we want to target. Of course, these were not clinical populations, but still there was emotional distress at the beginning because it's a 1-week measure. We found that the experimental group actually ended up showing greater reduction in emotional distress over the 1-week period compared to the control group. And note here that both groups are actually improving, but one group is improving more. And again, this was also related to the same PCC-DLPFC decoupling in the experimental, but not in the control group. Yep. So the takeaways here, 70 fMRI neurofeedback guided meditation training was used to deactivate the PCC, and we found PCC-DLPFC anticorrelation, which suggests improved control over mind wandering that also translated to improved mindful awareness of mental activity and management of emotional health. And these are also small to medium effect sizes. So what are the implications of this? I think for the neurofeedback literature in general, or anybody thinking about moving into neurofeedback space, training dosage matters. We found greater effects on day 2, but not on day 1. So who knows if we gave many more days, the effects would probably be higher, which has been found in some studies. But then fMRI neurofeedback is limiting in terms of expense. And it's important to conduct follow-ups over time to kind of capture effects that crystallize over time. And it's important to include a very strong control group because you can have a lot of non-specific effects, and we want to really capture the effects that are specific to the neurofeedback training. Ecological sampling is important to capture real-world effects, so please try to measure people in their real-world day-to-day life so that we can see what kind of effects such training paradigms have on the real world. And finally, multimodal exploration. So in this case, if you have a design like this, you can simply replace fMRI neurofeedback with EEG neurofeedback or any other modality and try to see how such modalities can capture these effects in the real world. I wanted to quickly just cover the limitations as well. So we've got a small sample size because it's a proof of concept study, but unlike a lot of proof of concepts, we had a strong control group as well. And ideally, you'd have a third control group where it's treatment as usual, so you don't have any neurofeedback at all, and they're just doing meditation as usual, which was not in this one. And it's important to consider the practicalities, as some of the earlier talks here. It's not really practical to put people into the MRI scanner and ask them to learn meditation with all the sounds and lying down still. So ideally, you would need something that translates and that's scalable and that you can implement in clinics and schools and households. So that we need to consider how this can be, taken forward from a multimodal perspective. And double blinding is important. So in this case, we're single blinded, but yeah, ideally you'd have a gold standard double blinding. And finally, yoke sham matching. So this is a very strong control group, but on the other hand, it's important to consider how you match the two groups in terms of the feedback. So in our case, we matched them based on meditation experience, but there are many other ways to match, and that's something we need to think about more. And I would like to finally thank my team and acknowledge my supervisor, Andrew, here. I have no disclosures either. And this is question time, and please visit my poster in the poster hall later whenever you have time. We've got time for questions for all the speakers. Thank you so much.